Eric, and we'll get it going. So, yeah, hit the ground running with open source GIS. Our guest speaker today is Eric Friesen, and Eric is a training specialist with Boundless. Soon to be changed names is going to be Planet Federal. He's worked with GIS and remote sensing technology for the past 13 years. Prior to joining Boundless, Eric spent 8 years as the sole GIS technician and analyst for a small oil and gas company. He earned a BS in geoscience and graduate certificates in GIS and remote sensing from the University of Texas at Dallas. In his spare time, Eric likes to tinker with electronics and the brew and beer and backcountry camping. So, Eric, tell you what I'm going to do right now is I'm going to make sure that everybody is muted, and we're going to turn it over to you. I'll let you do a summary of your presentation, and thank you so much for being here today.
Well, thank you. So let me move over to my slide deck really quick. As he said, the slide or talk is titled "Hit the Ground Running with Open Source GIS," and it's going to go in 3 parts. First, we're going to talk a little bit about just what is open source in general, and then a little bit of a deeper dive into specifically open source geospatial things. A little bit about some of the major players in the open source geospatial space, some of the companies that support it, some of the big users, some of the big projects. And then we'll wrap it up with a quick little demo of a few different workflows in QGIS. We'll see how much we can get in given the time that we've got. Hopefully I can get through it all, but we'll see. Open source software in general, what is it? I think we've got a couple of polls queued up for this one, probably about what do people's experiences with open source software amount to. Can you let me know when those go? Perfect. And not entirely sure how long those were on, sorry. Ah, 81%. Nice. Good, good. I will try not to get too basic about it then, and I'll do a higher level thing about it. So the next one. Yeah, have you ever used open source software yourself? Oh, nice. Okay. Yeah, that's a fair bit right there. The last one was a bit of a trick question, and I'd like to apologize in advance if there's any noise in the background. I'm in a hotel right now. It's been pretty quiet lately, but I think I hear some people starting to walk by. Before I go over the licenses, that last one was kind of a gotcha. If you're on a computer, you've used open source software. If you've got a smartphone, you've used open source software, whether it be something like Android or OS X, or sorry, not OS X, iOS, or even Windows, like Windows Phone, if you happen to have used that. They've all been built on top of open source software, whether it's a major component that's the foundation or subsets of it. Everyone who's touched a computer has used open source software. If you've been on the internet at all, odds are better than even that you've been served a web page by an open source web server. It's everywhere. It's a major foundation of our computing world now. Now, kind of getting into a what is open source software thing. Open source kind of refers to the licensing scheme. It's a framework built within the copyright system that is supposed to kind of subvert the copyright system, gives back to the people, make source code make the people required to give back, but not necessarily what you might think. A couple of examples of really common, really popular open source licenses that I'm not going to do with trying to sum here are the GPL license, QGIS, which I'll be talking is licensed under, and I think PostGIS and GeoServer are also. the Apache license, and that's actually named the same group that does Apache BSD license. And BSD is actually the operating system that iOS and OS X are based on. It's the type of Unix, and this is the license that used. And then you've got the MIT license, which is an incredibly permissive one, which legally formalizes that you can do whatever the heck you want with what you have your hands on at the moment. Different open source license. Some licenses are compatible with each other, some aren't. It's worth taking this website here, opensource.org/licenses.
Eric, you're breaking up just a tiny bit here.
And plugging.
Real quick here, yeah, and check your battery just to make sure. Someone said they thought they saw battery low, but yeah, please check it. A little breaking up, so we can just take care of here. Plug in with the headset.
There we go. Sorry about that.
It's okay. Sounds
all right, so kind of moving along, let's talk about, good to go. Let's talk a little bit about some examples of open source software. You got the classic one, Linux. It's a Unix-like operating system. I think the majority of the web servers in the world still run Linux. It's insanely popular. There's lots of different varieties. I'm actually delivering this webinar right now from Ubuntu Linux. I think it might be one of the most popular desktop versions. It's supposed to be pretty user-friendly, but I've twisted my installation of it to fit my needs, so it's not quite as user-friendly, but that's more on me than on them. Another great example is Android. Completely open source system. Google has additional things they put on top of it when they do commercial releases, but theoretically you should be able to get a hold of all of the source code for it. You've got Python, which I'm sure many of you have used, whether it's in the form of ArcPy or just more general scripting. It's an example of a programming language that's open source, and many of the really popular languages are open source. Java was, I think, one of the really big early ones, early in my lifetime. There's older examples, but that's the first big open source one I can remember hitting my radar. Hardware can also be open sourced. This is actually a ham radio board. The plans are all freely available online. You could etch your own, or you could just buy one from someone. The designs are fully open sourced, everything from the individual processors on there all the way up to the operating system-ish that kind of runs the whole thing. And in the same vein as hardware, it's even going as far as, you may have heard of 3D printed guns. The designs for those are commonly open source. And that's kind of an extreme example, but just kind of trying to show how open source touches a lot more aspects of life than you would expect. And speaking of, there's a lot of different parts of the open source movement. You've got the open source hardware, like I just mentioned, open government programs, which try to use open source models to either run their governments or their communications, so on. Open access, maybe you're familiar with the idea of open access scholarly journals, kind of trying to subvert the whole pay insane amounts of money to get access to your own research model. Open businesses, open cloud, anything you can think of. It kind of gets ridiculous all the way down to open pharmaceuticals, like companies openly collaborating on designing drugs to help people and using similar licensing schemes. Now, how do you organize open source projects? I'll go straight into examples from open source GIS here, but commonly you have governance groups. The two examples on this right here are the OGC, which is a standards body, and they come up with standards for interaction between GIS software. You may have heard of the Geo package, or maybe a WMS server, or a WFS server, or a web tile or web map tile server. Those are all standards managed by the Open Geospatial Consortium. And below that, you've got OSGeo, which is more of a project management for a software thing. They manage a lot of different projects, including QGIS and PostGIS and GeoServer. Actually, quite a few of my coworkers are directly involved with them. Very hardworking group, and a lot of times they do it on volunteer basis, just out of love of the community. So some pros of using open source software, specifically open source geospatial software, but a lot of these will apply in general. The cost is going to be the first big one. Then you've got reliability and security, which sounds a little counterintuitive, but I'll explain that. And then the community is a big plus. So cost in general, commonly open source software can be free, like completely free. People can charge money for it depending on the licenses, but there's always a way to obtain it for free if you're willing to put in the work. And if you're not, well, you can probably find someone else who was willing to put in the work to package it up for you. When it does cost money, it tends to still cost less than proprietary software. Yep, so I got those. So reliability, you've got a bunch of eyes on your projects. You get that many people looking at your code, people will spot bugs like crazy. And it kind of gets to be almost like a friendly competition, who can spot bugs the fastest or who can give the most thorough bug reports. So you get good, rapid fixes. Yeah. And transparency. You can see the communications process. They frequently happen out in the open, whether it be via GitHub issue reports or mail servers or listservs. You can see exactly what the developers are going through, and if you feel so inclined, you can usually contribute pretty easily as well. Security, and this is going to kind of look like a duplicate slide, but security tends to be good with open source projects for similar reasons. You've got a bunch of different eyes on your projects. You've got a bunch of people looking for security holes. You can fix those security holes very quickly when they're spotted. And again, you kind of get that competitive spirit of, I can do this. I'm going to get this hole patched quickly, and I'm going to rack up a high score or whatever. And transparency, again, you wouldn't think that everyone having access to your code would promote security. But when you have that many people looking at it and looking for problems, and it's out in the open, security holes tend to get fixed faster or be mitigated before releases even. Some kind of examples of the opposite with more closed source systems. If you have ever heard about some of the old DOS bugs that led to privilege execution attacks that can go back to the mid-90s that did not get fixed until about 2008. Like, they still turned out to be vulnerabilities for Windows 7 and Windows 2008 server. I heard about a more recent one, but I don't have decent details on that one. I think, it was a print spooler issue that also, I think that one continued until 2012, and it also went back to DOS. So no eyes on the code means it's not really getting taken care of. Now, you can have old security problems that take a while to get fixed with open source software as well. We did have an open SSH problem that was patched recently, but again, as soon as the problem was discovered, it was communicated and people collaborated to fix it versus not knowing about the problem until a patch is released or until a security researcher embarrasses the company that created the problem. Okay, and the last pro being community. Support is incredibly easy to find. It may be in a slightly different venue than you'd expect. Maybe you go to a Slack room or a Slack channel full of open source devs and you talk directly to them. Or maybe you just happen to be on a mailing list, or maybe you actually go to in real life meetups and talk to the devs and you have direct lines of communication that way. Funding is kind of interesting process through the community. You have major companies coming together with groups of users who pull their money, or even individuals who are just highly motivated to see projects flourish. So it's kind of interesting to see funding resources come together like that versus needing an investor and needing to sell it. You just find a bunch of users who really want a feature and they can pull their money together and have that feature rapidly developed. And direct involvement. You're using an open platform, often your developers can just go talk to the developers from that project and work directly together instead of having to work through weird different service platforms. What about training or integration or support at a professional level, at a paid level, well, those are all available. That's actually what the company that I work for does. I myself am a training specialist. We also do a fair bit of integration for clients, and we have paid support subscriptions. That's where we do our business. Now, a few cons you might think of with open source software. You might think it's not user-friendly, or that you can't find support, which the previous slide kind of nullifies that a bit. Or you might even think that you have a lack of ownership of your platform or your software or your data. I think, oh, sorry, I got ahead of myself. Yeah, have you ever used open source GIS software? Let's go ahead and do that poll really quick. Ah, okay, about the same as the last one. All right. I think there's one more after that. Oh, nice. A lot more QGIS use than I expected. That's great. I'd like to see PostGIS get boosted a little bit. That's a pretty powerful project. Same with GeoServer. Server. Anyway, as far as user friendliness goes, and we'll come back around to those polls in a moment. Honestly, user friendliness in open source software varies as much as it does in proprietary software. I mean, this was a screenshot of James Fee's installation of ArcMap. I mean, he was obviously being a bit over the top with it. He was trying to make a point about complexity in our desktop software. If you're using specialist software, it's going to be a little more difficult to use, but that's why you have a job using that software, is because you had to take the time learning to use it. But you can look at examples of open source stuff that's easy to use, like, again, Android, or actually, Android's a great example. I just got my grandmother her first cell phone, and she's 95 years old. I got her an Android phone, and she's just kind of rolling with it. The last time she touched a computer was in the days of Windows 95, so she's not too up to speed on things, but she can pick it up and run with it. I mean, I wouldn't expect her to run with QGIS or any database software, but that's because it's specialist software. You're going to have to do a lift to learn either way. Lack of support. There's plenty of support options. As I said earlier, you've got your free options of direct communication with the developers and the organizations that help write the software. You've got paid options, like Boundless is a major player with that. There are other companies ranging from mom and pop shops all the way up to other giant companies that will do paid support, paid training, paid integration, customization, so on. If you can go either route, or you can kind of go a mix of routes. If you've got a mission critical system, I'd recommend you pay for support, just like I'd recommend that you pay for support with proprietary software. It's just nice to be able to call someone at 3 in the morning if your server's down and have that accountability. The lack of ownership one. I've heard out at happy hours and social events and things like that, that some of the complaints are that you don't own the software if it's open source, it's community. Well, you don't really own your proprietary software either. You're still just paying for a license that can be revoked at any time. And in fact, it's kind of less likely to be revoked with open source. You have to go out of your way to offend someone for that to happen. I've also heard people say that if they were to use open source geospatial software specifically, that they would lose ownership of their proprietary data. And that's just not true. There are examples of things like OpenStreetMap that have licenses, where if you intermingle your data with theirs, that you have to contribute that data back. But that's not an open source software license as much as it's a database license. You're licensing their data, and they're making it a requirement. If you integrate it with yours, you have to contribute back. If you're doing an analysis in QGIS, no one else owns your data, no more than they would if you were doing it in ArcMap. Same with doing something in PostGIS versus doing it in SDE or in, can't remember the name of the one that many cities like to use to share their data, that you still own your data. So those are all kind of not really cons. I can't think of any cons off the top of my head with open source data or open source software that only apply to open source software and aren't general cons of software in general. Repeating myself there. So we had that question earlier about whether or not you've used open source geospatial software. The answer there is every one of you have used ArcMap or anything like that have used open source geospatial software. There's quite a bit of open source tooling built into it, from the libraries that read you rasters out to you to various processing libraries. Esri went hard in on open source spatial years ago, and even the old ArcMaps were built on top of some open source components. So you've already been using it. Some example of bigger open source geospatial projects. I mentioned OpenStreetMap previously. In addition to all their data, they actually have an implementation of their server that you can run on your own. It's kind of a weird one though, because it's actually not a spatial server. It's a graph server. It doesn't have any real geo aspect to it. It kind of gets forced into it via a very odd side means. You have things like GeoServer. It's kind of a middleman between either your desktop or your web client and your databases, or flat files that you may have stored on it. It can even provide processing services. You have PostGIS, which is an expansion for the Postgres database. And it just basically makes it so that you have your Postgres database and your spatial data is just another column in the database. It provides support for handling projections. It'll let you do all sorts of analysis. There are network analysis plugins that build on top of PostGIS that are incredibly fast and powerful. You've got QGIS, which I'll be talking about more later. Think about it like a open source alternative to ArcMap or ArcGIS Pro. You've got similar functionality, loading in all sorts of vector and raster data, performing all sorts of analysis, generating print maps, but no licensing levels. You just get all the geoprocessing tools out the gate. GeoNode is an interesting one. That's kind of a collaboration system. It works pretty well with GeoServer. You can kind of think about it like our GIS portal. You can point it at different servers within your network or upload files directly to it and use it to collaborate. People in disparate locations can each have their own spatial data server, whatever it may be, whether it's PostGIS or GeoServer. You can actually point it at some Esri products as well, and it can integrate with those. And it's a good central repository for all your geospatial data. This is an interesting one that you may have seen in the news or on Reddit or something. It's an Uber project. It's a JavaScript library for visualizing large data sets in the browser. It's really, really interesting. I haven't got to play with it as much as I would like, but it seems incredibly powerful and it makes beautiful visualizations. Then you've got GDAL, which is one of those libraries that I mentioned. I don't think I mentioned it by name, but that's the one I was referring to when I was talking about loading raster data into ArcMap or QGIS or PostGIS or lots of other software. Many packages use GDAL on their backend. And it has a sibling library called Ogre. And Ogre is basically, it does the same things as GDAL, but it does it for vector data. They've been around a very long time. Some major users of some major users of open source GIS software. One of the Boundless's clients, and sorry about going back to Boundless a lot. That's my home, so that's what I'm most familiar with. That's where I can get the examples the easiest and speak to them the best. Farmer's Edge does imagery for large-scale precision farming, and they produce prescriptive maps for things like watering and fertilizer. And they use GeoServer. Specifically, they use a managed variant of GeoServer that scales using, I think, Docker to help it out, to deal with large data sets and rapidly process them. Monsanto does similar. TriMet, which is the Portland mass transit system, makes use of, what do they do? I know they've got PostGIS on the back end, I think GeoServer. Server. The New York City Department of Information Technology and Telecom, I skipped down a couple lines. They plan out their routes and keep track of where the cables are laid out using open source geospatial software. The petroleum industry is getting into it pretty big now. When I left a year and a half ago, I kept getting odd looks for suggesting open source GIS solutions. And that's where I heard a lot of those arguments about losing ownership of your data. Now, when I go to social functions with people I used to work with there, I get a lot more questions about how they can adopt things like QGIS and PostGIS and GeoServer. There's a lot of small companies out there that do petroleum, or even a lot of big companies that have to tighten their belt unexpectedly. So they'd like to keep their costs down as much as possible up front. So they're starting to look to open source. The Louisiana Department of Health and Hospitals, they actually have an emergency management map that relies on Boundless's version of GeoNode. You might have seen an article pop up in a few different geospatial trade news websites or magazines or whatever, talking about, I think it was Hurricane Harvey, one of the more recent hurricanes, and how they were managing their data in that. The federal government uses open source GIS a fair bit. The National Geospatial Intelligence Agency is a large user, and they just keep adopting more and more. They're very big into QGIS and PostGIS and GeoServer and GeoNode. They love all the things. They're large participants in the FOSS4G conferences, the free open source software for geospatial. At the most recent North American one in St. Louis last year, they had a large presence there in terms of people there to attend talks and such, and to network and to do some recruiting. And one of their C-level people actually gave the keynote at that conference. The NSA also participates quite a bit in open source geospatial. They actually have a GitHub page where they've got some amazing QGIS plugins available that they've developed. I used one of those back in my oil days to help me plot surveys and such. Some companies that you might hear, might not have heard of. You've got, as I said, like small mom and pop shops like Kurt Menke's Bird's Eye View. He's out of New Mexico. Does amazing work. You've got larger ones like Electric Consulting. They are a driving force behind the development of QGIS alongside Boundless. Carto, you may have heard of them back in the days when they were called CartoDB. They do hosted PostGIS instances and have amazing visualization tools for it as well. We've got another company called Crunchy Data that's also big into PostGIS. I actually think one of the guys who is responsible for the creation of PostGIS might work for them right now. I can't remember off the top of my head, but I'm pretty sure. Got Boundless, my employer. We're actually going to be called Planet Federal soon, probably. We're in the process of being bought by Planet, the satellite imagery company that has that enormous fleet of tiny satellites that image the Earth twice a day at a ridiculous resolution. Definitely looking forward to working with that. You've got Esri. They're actually a large contributor to open source geospatial development, whether it be open sourcing their own projects or contributing to the development of existing large, important libraries that are critical for the entire community. They play very well with the open source community. So paid services, I kind of already talked a bit about those. I won't go back into them too much. You've got all the usual paid services you'd expect from software. You've got your paid support options. We at Boundless have our automated support systems and our call someone at 3 a.m. support systems like any other software company would. You've got your training options. I'm out in England right now delivering trainings to one of our customers. I actually wrapped up my day about 2 hours ago. But yeah, I started out a first day of teaching people about QGIS. And integrations. Any large software you bring into your organization is going to have to be integrated with what you've already got in place. And paid support, open source players, they do it the same as any other proprietary software company would go. Whoops. Ah, nice. Okay. So on to QGIS. Ah, it's coming along all right. I'm going to go ahead and open up QGIS and give you a quick little tour of the interface. A lot of it will probably look pretty familiar to you. So this is what it looks like when you open up a fresh instance of QGIS. I've got some projects that I'd previously been working on, or little side things that I've been tooling around with, trying to figure out some cartography. You've got all your usual menus across the top. Instead of a file menu, you've got project, but you find the usual file menu things in there, your edit menus for copying and loading data, all the usual stuff. Down the left side of this, we've got shortcuts for loading different types of data, for adding vector layers, raster layers, specifically for adding layers stored in spatial-like databases and PostGIS or other database servers like Microsoft SQL or DB2. We've got things for WMS servers or tile servers, along with feature servers and coverage services. And of course, delimited text files like CSVs and tab separated values and so on. Then up across the top over here, we've got your usual navigation tools, a little hand tool for panning around the map, zoom to my selected features, box zooms, zoom to full extent, and so on and so forth. If I were to go load in some data really quick, let me find what I was going to bring in here really quick. Let's say, where did it go? Say I want to bring in a DEM. I need to be in the correct loader for that first. Go into add raster right here. I'm going to go ahead and bring in a reprojected. No, I'll go ahead and bring in my original Wake County Mosaic. Where'd that go? And my interface looks a little bit strange right now. That's mostly just because I'm in Linux, not Windows. It might look a little bit odd, but it'll use whatever file loader you typically like to use. Where did you go? Sorry, I've misplaced my data. I had all my shortcuts set and didn't reset them after I left class today. All right. There we go. So I'll load in a couple of DEMs. There we go. I'll go ahead and zoom to the full extent of them. So we've got two DEMs loaded. You've got the usual differences in visualization just because of the different ranges of values contained in each of them. But normally you'd want to say make a mosaic of these. But to save space, I'll use an interesting little QGIS feature that allows us to kind of make a virtual mosaic. It's called a virtual raster or a catalog. And instead of generating a new raster file, it will just make a little XML file that tells QGIS how to treat it as though it was one large raster. So rather than pick input files, I'm just going to choose the ones that are already in there. I'm going to go ahead and tell it to output as DEM vert. That'll work. Okay. I'm going to leave everything else as it is. It should use the projection that both of them are already using. And it should continue with the, since they should be the same resolution because they're the same sort of data source, I don't need to mess with that. So I'll hit OK and let it do its thing. And once it's done there, we have a brand new mosaic that isn't a mosaic. It's not taking up any extra space in your storage. It's just maybe like a 4 kilobyte file that tells QGIS how to display it and do processing with it as though it was a full mosaic. So I'll go ahead and get rid of these two now that we've got a combined layer there. And now let's say I want to clip it. I'm going to go ahead and, so all of this is in the Raleigh, North Carolina area. A lot of our training exercises have used Raleigh data just to be consistent. I figure I'll go ahead and keep going with that since I'm already kind of familiar with it, and it'll be a little lower friction. So I'll bring in a boundary layer. Let's see, we've got the Wake County boundary right here. So there it is on top of our raster, and we can use that to clip the raster like you would, like you'd expect to be able to do. So I'll point it at our mosaic. We'll give it an output file. I've already got one in here from when I was testing this earlier. So I'll just call it Wake Clip 2, just so we have a new one written. And this is going to go ahead and write out a GeoTip. You might have noticed that this was a grid file that we're using as inputs. But we'll go ahead and write it to GeoTip because that's what QGIS tends to prefer. It can work with plenty of others, but you'll have the easiest time with that. I'm going to set my clipping mode to the mask layer. I'm going to use the wake boundary as that. And we'll go ahead and make sure that we crop the extent to down to that as well, so we don't have a large black border that matches the previous rasters. So let that run for a second. Oop, I forgot one important thing. I forgot to put TIFF at the end of it, so it wasn't sure what file format I wanted to output. Just that little bitty extension. There we go. And down in this little box right here, you can see the GDAL command that's actually run. This tool is just a front end for a command line GDAL instance. So we'll run that. It'll take a second. Hopefully not too long. I've got this thing. There we go. So now we've got our clipped file. It's got the usual black band around it from no data values. I'll go ahead and throw out that mosaic. And then let's clear up this raster real quick, just so we don't have to see the no data values. To do that, I'm going to use something over on the right side of the screen called the layer styling dock, or the layer styling panel. You get a lot of different options in here. This is what it looks like when you have a raster layer loaded. And I'm going to go down to transparency. I'm going to go ahead and tell it to set the transparency band to, well, let's find out what those values are for the node data. And I use my identify tool right here. It pops up another little panel. And all of these panels can be split out as windows like you'd expect to be able to do. So we've got our value that's being used for node data. And I'm just going to right click on that and copy the attribute value. And then I'm just going to go ahead and drop it in here as an additional node data value. And that clears that right out. So there we've got our raster that has been clipped, and it is missing that node data band around it. And let me get rid of this highlight by turning off the layer information tool and panning around a bit. I'll go ahead and close out this panel. And now let's bring that wake boundary back up on top of it. We can start to do some neat visualization. One thing that I really like to show off with the way that QGIS can handle data visualization. So we've got a DEM file right here. It's the raw DEM data. But let's say we'd like a hillshade. I can just go down here. Where'd you go? Important aside. Whatever layer you have highlighted in the layers panel, any tool or any setting that you try to adjust, QGIS is going to assume that you want to work with that layer. So I'll go ahead and highlight my DEM over here. I'll go pick a hillshade renderer. And just like that, aha, I broke something. Oh, I know what I did. First, I need to set it to an appropriate projection. Let's see. What do we want to reproject you to? So to reproject rasters, you're going to use the warp tool. It works just like you'd expect reprojection to work. I'm going to pick an appropriate projection that uses feet or meters instead of using degrees. I think this one should do it. I might need to actually tell it the name of the file to put out there. So just like last time, I'll stick a 2 on the end of this just so we can write a new file. Nope. Let's see. I almost set the wrong source projection. You might notice in this menu for dealing with projections, you can filter by the EPSG codes. You could also just type out a name to narrow down your list. I usually try to just remember the EPSG codes because it gets you there faster. I'll bring that back to what it's supposed to be. Now I'll set the target projection to one that uses feet. Let's see, we'll do 2264. Okay. So same deal, we've got our raster. Go ahead and set that no data value again. And just in case it changed, I'll go ahead and copy this out, do that all over. Come on. Oh, I had the wrong layer selected. That one's giving me a little bit of trouble. I'll go ahead and try using this other alternative we've got. You can give ranges of values to set as transparent as well, and you can give them varying amounts of transparency over here. So I'll just set a one item range. Let's see if I can get that one to do it here. No, you're not going to work with me? All right. Rather than make you all watch me figure out what step I'm missing here, I'm going to pull in the one I generated when I was helping the URISA people test the connection earlier. Let's see. Add a raster layer. I'll go to my output data folder. And I'll pick this reprojected one right here. So you might see down in the bottom right corner, it's still using EPSG 4269, and that OTF means it's doing on-the-fly reprojection. I want to go ahead and change my project to match my raster layer. So I can right-click on that over here in the Layers panel and just set the project projection using that. And now we can try doing that hillshade again. Hopefully, it sorts itself out. There we go. Now, I'm not sure what resolution it's coming through at, so I'm just going to crank the Z factor way up, get some good vertical exaggeration going on that. Let's make it nice and dramatic. Then, let's say I want to add a little bit more character or a little bit more visual information to it. I'm going to go ahead and duplicate this layer and visualize it a second time, but using a, I'm going to go ahead and do a single band pseudocolor visualization. And I'll just go with the default settings here. I'll tell it to load in my min and max values. So now we've got a colored representation of the elevation. And if I scroll down to this blending mode setting right here, I can use the multiply one to combine those two layers. And now you have a 3D effect on your colored relief map. Those two layers are just a single layer on your drive, just a single layer in memory, just two different representations of them. And then you combine the visuals. What else do we have here? If we want to mess around with a little bit of vector data, I'll go ahead and turn these off and zoom back up to our wake boundary. And I'll go ahead and actually hollow that one out because I don't want it to be colored in. I can just go to our color picker here. And this is actually the shortcut color picker. That's not the technical term for it. It's just how I always remember it. If you actually click on the color, you get a much more in-depth option. You have commonly used colors, your default colors, and you can also set default colors at the project level. I'm going to go ahead and actually just set it to completely transparent though. And the fastest way to do that is with this little drop down menu. There we go. Now we've just got a boundary. Let's say I'm looking at Wake County and I want to get a feel for what sort of police coverage we've got in the area. And I've got some data about our police stations. We'll look at a specific township. We'll look at, let's say, Meredith Township. That might not be enough points. Let's see, maybe we've got a better one. Go ahead and grab one from my training files. It actually has the whole county. Well, over here, I should have the file representing all the police stations in the county if I were to look at my source data instead of my output data. There we go. So yeah, here we go, police stations. I'll bring in that shape file. There we go, we've got a few more on that. But let's say I want to kind of visualize what zones they cover. Could go into our analysis tools and generate some Thiessen polygons representing them. Where'd you go? Oh, research tools. Nope. Another neat option when you're looking for geoprocessing tools is you can go to this processing toolbox by default over on the right. It's another tab next to the layer styling. I can just search for the tool that I want. So here we go. So I'll go ahead and point it at the police stations layer. I'll set a buffer region, and this is going to be in map units. Since this is in feet, I'll go ahead and set it to something relatively large just to stretch the generated polygons all the way up to the county boundary. And I'm going to go ahead and just create a temporary layer instead of writing a permanent file. This is just going to be like a virtual shape file or something along those lines. It's just kept in memory and it only exists within the context of the project. If I'm happy with it, I can always take it and export it to a more permanent file. So those buffers were a bit big. Now let's see if we can do a little better. Let's just set it to 10. There we go. It doesn't quite cover the county, but you get the idea. Again, I'll go ahead and clear out the fill on this a little bit just so we can have an idea of what they contain. Highlight the newly generated virtual layer. Go back over to my styling panel. And over here, you have your symbology builder. Right now, it's just got a single layer of symbology. It's just a simple fill. So I'll go ahead and change it to what's called a shape burst fill. And that kind of makes a neat little effect. And if I set the fade color instead of white, if I set it to transparent, you can see through them. Right now, it's just, we're looking at the data frame or the equivalent of the data frame. So the visuals scale with you. If we were doing this on a print composer, it would stay a consistent size. I'll go ahead and add in, let's get a base map on there so we've got some context. Let me make sure I've got my base map plugin going. And this is a good time to talk about base map plugins, or plugins in general. Everything in QGIS is a plugin, or almost everything. The like very base UI itself is not, but there's a few kinds of plugins, like the database manager here is what's referred to as a core plugin. You'll notice down over here, all the options to uninstall it and such are grayed out. It's because it's built into QGIS, but QGIS is modular, so you can turn on and off bits of it. What I use when I'm just kind of exploring for base maps is a plugin called QuickMap Services. And this is a third-party plugin. You've got your controls for upgrading it or uninstalling it or reinstalling it if you need to down here. Over on the right, you've got a little panel that gives you a description, maybe contact information for the authors, version history. And kind of an idea of where you can find it. So that's turned on, and I can tell that because that box is checked. So I'll close that. I'll go up to this little menu up here called Web, and that's where it's found. And let's just throw an OpenStreetMap layer on that. We'll give it a standard one. So those polygons are a bit loud on that. I'm going to set it to shade to a shorter distance, make it just kind of look a little bit glowy. And then if we wanted to take this and let's say generate an actual print map from it, we'd use another part of the QGIS interface. And I know we're getting pretty close to time here, so I'm going to wrap that part up and see if you've got any questions. I'll just pull up that interface really quick. That's going to be under your project menu over here. And that'll be your print composer. I'm just going to call this test, just so I don't have to think about what to call it. It pops open a new window, and unfortunately for me, it popped it open on my other monitor. Here we go. And this is kind of like the layout manager in ArcMap, but it's a little bit different. I encourage you to read the book QGIS Map Design, or check out Anita Grauser's blog for some amazing advice on how to use this. We'll put the equivalent of our data frame on here, and it'll just be zoomed to the same position. And we can do all the usual stuff like scale bars. We can adjust those, change the units that we're using for them, and so on. We could drop a north arrow in here. That's kind of an interesting one because you would think it would be this add arrow tool, but no, you're actually going to add an image. That will be over here on the left. You actually just pick out an arrow SVG. I'll just go with this one. And you set it to sync with north on the map. Then you can sync it to grid north or true north. You've got all the usual stuff. And actually, let me put a legend on there just for the sake of completeness. You can pretty these up pretty well. But I rambled so long at the beginning of this that I'm not going to be able to get into the details of that. If you'd like to know more, y'all can contact me or check out the books I suggested or check out some websites I suggested. Let me bring it back to the slide so I don't go way over. Let's see here. Oh, I brought this up just to show you an example of an intelligence agency contributing to open source software on GitHub. Back to so a few resources to wrap things up. In terms of commercial support, obviously Boundless, my employer, we do a fair bit of it. OSGeo, that organization I previously mentioned, actually has a list of paid service providers that it works with. We're one of them. Some major project websites to check out. Again, OSGeo, it has links out to all of its child projects, and here are the ones. Oh no, my PostGIS link's broken. But just QGIS.org, PostGIS.net, geoserver.org. I can get you links to all those after the fact as well. And then for closing, here's some contact info for me. There's my email address, personal one, work one, depending on what you want to talk to me about. And if you want to catch me on social media, Twitter's the one that I'm actually active on, and I try to only talk about geo stuff on there. And anyone have any questions?
Very nice, Eric. Sure do appreciate it. If you do have some questions, we're getting pretty close on time here. I'm going to go ahead and unmute Ollie if it'll let me here. But yeah, if you have any questions for Eric, please go ahead and send them to us to our email account and or type them into the chat menu pretty quickly, and I'll try to read it off for him. We will post the titles of the books again, and make sure that it's put up on our website, so you can go to the website there and you'll be able to see that there. We will definitely send out PDHs after this, and so let me see here if I can get Ollie. Ollie, are you?
Yeah, I'm here.
Perfect. Anything we need to add, Ollie?
Just if you didn't sign up for the event on our website, if you can shoot us your email address so that we can make sure that you guys get your PDH certificate.
Absolutely. And let's see, Courtney. Yeah, Courtney was asking for the book resources, and we'll get that to you, Courtney. But and yeah, like I said, if you have any questions whatsoever, go ahead and send them to our email address there at URISA, Texas, and we will pass them on to Eric. And Eric, we really appreciate you sitting in with us. I know there's a time difference over in England, and
oh, it's all right. It's post work, so it worked out pretty well for me.
So, the last thing, everybody, looks like we had, at my count, 77 at maximum attendance today. Wanted to let everybody know that we will be downloading this and posting to our YouTube channel recording of this, so you can go back and rewatch it if you had to step out for a few minutes or not. But we'll send that out, and the web link for YouTube will be posted on our website. So please stay tuned for our next speaker series in February. Ollie, that is what date have we got that one?
Great question.
So,
it will be February 19th.
Okay, so please check that out on the website, and please join us again. So, well, it's 1 o'clock, and we appreciate everybody attending the URISA Texas Speaker Series once again. So we will catch you next month, and enjoy the rest of your day. Thank you all.
Thanks,
Thank
everyone.
you. Have a good one.
Okay, thanks, Eric.